Assalamualaikum warahmatullahi wabarakatuh. Okay, my name is Nur Muhammad Nasruddin. I from Group 10, and my group, my title group is chemistry, nuclear magnetic resources. Okay, so first slide is this is example history. Okay, so you can look at this. Okay, and the second slide is history of NMR. First, NMR spectra on water. Okay, this is an example of our picture. Okay, 1H NMR spectra of water. Okay, this is a example of introduction of NMR. Okay, the sample is dissolved in solvent in a tin NMR tube and placed in a magnetic field. Okay, so in the NMR probe, the sample is rotated in a magnetic field and irritated with a short pulse of RF radiation. Okay, this is the example our process NMR. Okay, you can look at this, and the result is get the computer. Okay.
Assalamualaikum. My name is Muhammad Nuridwan bin Yusuf. Today I want to present about theory NMR. In a magnetic field, there are two energy states for a proton. A lower energy state with the nuclear electron in the same direction as B, and a higher energy state in which the nuclear electron again B. Okay. When external energy source that match the energy difference between these two states, it is applied energy is absorbed, causing the nuclear to spin flip from one orientation to other. Okay, the energy difference between these two nuclear spin states correspond to the low frequency RF radio of the electromagnetic spectrum. Okay. Next, when a charged particle such a proton spin on its axis, it creates a magnetic field. Yes, the nuclear can be considered to be a tiny bar magnet. Okay, normally these tiny bar magnets are randomly oriented in space. However, in the present of a magnetic field B, they are oriented with or against this applied field. Nuclei are oriented with the applied field because this arrangement is lower in energy. Okay, that's all.
Okay, Assalamualaikum. My name is Muhammad Hanif bin Ismail. Okay, today I will like to present about the type of NMR spectra. Before I start more detail about the type of NMR spectra, so the first thing that I want to present to you, what is the spectra? Okay, what is spectra? Spectra is the data analysis that they collect from the NMR system. So spectra is the wave of the graph. Okay, now let me see with the first type of NMR spectra. The first type is the white line spectra. White line spectra are those in which the bandwidth of the source of the line is large enough so that the fine structure due to chemical environment is observed. A single peak is associated with each species. Okay, now let me see with the graph. This graph will show the absorption and magnetic field combination. That is the reflection of magnetic field. Okay, let me see the wave of the graph. You can see the different type of species, different type of protons. That is the types of the white line spectra. Okay, let me see with the second types of NMR spectra. The second type is the high resolution spectra. Most NMR spectra are the high resolution and they are collected by instrument cable of the difference between the very small frequency, different of the 0.01 ppm or less. In the lower resolution spectrum, for the proton in external, 3p are observed arise absorption by the CH3, CH2 and OH proton. But in the higher resolution spectrum, two of the three peaks can be resolved in the additional peak. Okay, that is the types of NMR spectra. There are two types that, so I hope you all understand what I'm trying to explain to you. Okay, later my friend will talk more about the NMR system. So, check it out.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Now I will proceed with the effect of nuclear magnetic resonance. Okay, as we can see here, this is a spinning proton that creates a magnetic field. There is a two type of different way which is affects the nuclear magnetic resonance. First, as we can see here, it is effect of nuclear magnetic resonance with no external magnetic field. Okay, this is where the magnetic are randomly oriented. The second way is in a magnetic field. In a magnetic field, the nuclear magnets are oriented with or against B. So, in effect of magnetic field, we must know that the frequency needed for the resonance and applied magnetic field strengths are proportionally related. As we can see in the picture here, that this V is the frequency needed for the resonance and the B naught is the magnetic field strength. So they are proportionally related. Why? It is because when the magnetic field is stronger, then the larger energy differences between two nuclei in a spin states, and this will cause the resonance needed is higher. Okay, next I will proceed to the principle of nuclear magnetic resonance. Okay, we must know first of the principle of magnetic resonance. We must know that the solvent used in that is placed in magnetic field or in a sample tube is deuterochloroform. Okay, CdCl3 is the deuterochloroform. And after that, a radio frequency generator, it will irradiate the sample with short pulse radiation, and that will cause the resonance. And the third one is when the nuclei fall back to their lower energy state, the detector will measure the energy release and the spectrum will be recorded. So, to make you more clear, we can see this schematic diagram of NMR setup. Okay, we can see here, this is the radio frequency generator. Okay, so this is the sample tube which has the source and knots. The sample tube we use the CdCl3 just now. Okay, this is a detector and amplifier which is used to record the energy release. And lastly, it is a CRT display which can show the result that we get. That's all.
Assalamualaikum, my name is Roy Hasli binti Abdullah. Okay, so now I will explain about the principle of MNR. Okay, the principle of the MNR is proton is different environment absorbed at slightly different frequencies. So they are distinguishable by NMR. Okay, the second principle is the frequency at which a particle proton absorbed is determined by its electronic environment. The third is the size of the magnetic field generated by the electrons around a proton determines where it absorbs. The principle of NMR is modern NMR spectrometer use a constant magnetic field strength PO, and then a narrow range of frequencies is applied to achieve the resonance of all protons. Okay. For the chemical shift, the relative energy of resonance of particle nucleus resulting from its local environment is called chemical shift. NMR spectra shows applied field strength increasing from left to right. Left is a part of downfield, the right is upfield. Nuclei that absorb on upfield side are strongly shielded, where nuclei that absorb on downfield side is weakly shielded. For the chemical shift, the electrons surrounding a nucleus affect that effective magnetic field sensed by the nucleus. Okay, from this slide, you can know that this is the downfield and this one is the outfield. Okay, for the downfield, this proton sense a large effective magnetic field, so come into resonance at a higher frequency. This is the high frequency of the magnetic field. Okay, for the outfield, this proton sense a smaller effective magnetic field, so come into resonance at a lower frequency.
Assalamualaikum warahmatullahi wabarakatuh. My name is Sakira Binti Ramli. Now I want to present about types of carbons NMR spectroscopies. Okay, first is sample is measured using repeat accumulation of data and averaging of signals, incorporating pulse and operation of Fourier transform. And all signals are obtained simultaneously using a broad pulse of energy and resonances recorded. Because repeated pulse give many sets of data and are averaged to eliminate noise. For these transforms of average pulse data gives spectrum shown in next slides. Okay, for next slides is this is an example of 30 carbons NMR spectroscopies. I want to present about the structural organism hydrogen NMR spectroscopies. In hydrogen NMR spectroscopies, proton NMR is more sensitive than 30 carbons and active nucleus. Hydrogen is nearly 100% of the natural evidence. Show how many pairs of non-covalent hydrogen are in the compounds. Theoretical equivalence can be predicted by a C in replacing each hydrogen with X give the same or different outcome. Equivalent H have the same signal with a non-covalence are different, and as such may cause addition splitting the estropic effects. Next is about the this is example of NMR spectroscopies. For this a structure of CH2 and CH3. Hydrogen are unrelated and have different NMR adsorbs. This example of the two replacement products are constitution isomers. Okay, for the summaries, nuclear magnetic resonance spectroscopies basically provide the details information about the structure, dynamics, reaction state, and chemical environment of the molecules.
From our group, thank you for watching this video, and Assalamualaikum warahmatullahi wabarakatuh.